Hello, Assalamualaikum and good day everyone. My name is Jana Zamri and as the manager of Fly FM company, I would like to welcome you to our presentation about our latest project. Without further ado, my team and I present you Flight Display by Fly FM. In this presentation, we'll share with you some background and our objectives of the project. Next, you'll get to know the components and software used to complete this project. We will also share about the project operation, such as the subsystems involved in this flight display. This project uses the knowledge and principle from power subsystem, onboard data handling subsystem, as well as communication subsystem. And lastly, we will talk about the cost needed to complete this project. At the end of this presentation, you will get to see the demonstration done by one of our engineers where he will show you how this flight display works. Before diving further into the main content, I would like to tell you a little bit about Fly FM Company. So, Fly FM Company is a group of dedicated entrepreneurs and engineers aiming to provide exposure to those who are digging their teeth in the instrument field in the aviation industry. To provide a simple platform which is accessible to all layers of society is the aim of Fly FM. Now, I would like to introduce you to my team members. I am Jana Zamri, the project manager. We have Halimatul Rahmat as the project designer. We have Farah Anissa as the project integrator. Amirul Afiq and Fitri Zailan as the programming engineers, as well as Al Iqbal as the project analyzer. With that, I would like to pass the time now to the project integrator, Farah Anissa, to explain you the background of this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farah Nisa binti Muhammad Yusuf and I would like to give a brief introduction about our project. A primary flight display, which also can be called as PFD, can be found in an aircraft, which an instrument to be used for pilot's primary reference during the flight. These flight displays are important to any flight because it will provide the vertical navigation for the pilot to have some idea of the plane current trajectory when doing pitching up and down and also during the turning. For our project, we would like to propose a mock-up of the real flight display by implementing the same theory used in the real flight display, but we'll be using it in the form of Arduino. These are the objectives that we want to achieve for our project. The first one is to develop an intelligent interface for flight parameter by using the Arduino. The second one is to evaluate the ability of the interface to display all parameters. And the third one is to test the concept of redundancy for the project for the power system. These are the parameters that we would like to measure, which is the pressure, altitude, temperature, and also altitude indicator. This parameter could be obtained by using component and hardware in our Arduino, which will be explained more by Amirul Afiq. Thank you.
Assalamualaikum. My name is Muhammad Amir Rafiq and I will explain about the component and software used for our project. For the hardware, we use two Arduino, which are Arduino Nano and Arduino Uno. Arduino Nano used to operate all the sensors, while Arduino Uno used for artificial horizon. By doing this, we can help to increase the performance and stability in our project. For sensor, we use BMP280 to measure the pressure. For the artificial horizon, we use MPU 6050, and while for GPS, we use Neo 6M GPS Special. And for voltage booster, we use XL6009 DC-DC step up, and for the display, we use two displays which are Nokia 5110 LCD and LCD 1602. For the power, we use two lithium-ion battery with capacity of 2400 mAh and a charging port which is type C. And we also use battery holder and battery indicator to indicate remaining battery left in our project. For the connectivity, we use two mini breadboard and a lot of jumper wire to connect all the sensors. And we also use HC05 Bluetooth module for connectivity. We also use heatsink in order to reduce the temperature in our project. We use three software in our project. The first one is Arduino IDE. This software used to write a coding of the sensor and later this coding will be uploaded into the Arduino. Next, we use processing tree software to write a coding to display the artificial horizon. And lastly, we use MIT Avionic to create an application for the live data monitoring. Next, we move to the power subsystem of our project. First, we have Type-C charging port to charge our lithium-ion batteries. This charging port is connected to the battery holder. In this battery holder, these two lithium-ion batteries are connected in parallel in order to apply the concept of redundancy. If one of the battery fails, all the sensors still can give a reading by using only one battery. Since these batteries are connected in parallel, so the output voltage come from the battery is about 3.0 volt. However, Arduino Nano need at least 5 volt to operate. Therefore, we use SL6009 DC-DC step-up voltage booster to boost up the voltage up to 7.4 volt. Therefore, this NS voltage can be used to power up the Arduino Nano and then to power up all the sensors in our project.
I will be substituting Halimatur Rashmat for onboard data handling subsystem. This is our FlyFM mobile app. Once the connect button is clicked, the GPS will give out low signal or good signal. Pressure will be in kilopascal, altitude will be in meters, and temperature will be in Kelvin. The altitude indicator and the compass will be displayed on the laptop.
Hello guys, it is me again, Jana Zamri, the manager of this project as well as Fly FM company. I will explain to you about the communication subsystem which is used in this flight display. So the primary goal of communication subsystem is to provide a link to relay data findings and send commands to and from the satellite. So how does this Arduino send data in this project? We provide two types of data transfer, which is one using Bluetooth connection and the other one is by using wired connection. For Bluetooth connection, the smartphone needs to be connected to the Bluetooth module through the app to receive data. Meanwhile, for wired connection, the data will be sent through a USB cable that is connected to the Arduino and could be seen in serial monitor. Next, I will talk about the cost needed to complete this project. To build this flight display, we spent about Rm 162 ringgit and 70 cents to buy all of the components. Arduino Nano and Arduino Uno cost us about Rm 50 ringgit and Rm 20 ringgit respectively. The Neo 6 and 3PS sensor cost us about Rm 19 ringgit 90 cents. The other sensor like MPU 6050 and BMP 280 were bought at Rm 5 ringgit 90 cents and 7 ringgit 90 cents respectively. HC05 Bluetooth module is Rm 14 ringgit 90 cents, while Nokia 5110 LCD is Rm 12 ringgit. Next, the LCD 1602 cost us about Rm 10 ringgit 90 cents. For the other components, aside from the ABX box, you can get them under 10 ringgit each.
Hi, my name is Muhammad Arifin bin Sataria and I will be presenting about the conclusion of our project. There are three suggestions to improve our project, which is better heat dissipation, better portability, and better connection range. For better heat dissipation, the problem comes from space constraint due to the casing. The easiest solution is to just drill extra holes on the casing, thus more air can go inside the casing, thus cooling the system. For better portability, it is due to the inability of the battery to provide sufficient power to one of the Arduino that powers the artificial horizon. To overcome this, it is advisable to use a more powerful rated lithium-ion battery, which can provide a more stable power towards the Arduino system. Next is the use of a cable that connects the Arduino with the serial monitor. We suggest to just use a transmitter and a receiver so that the cable can be removed completely. For better connection range, the problem comes from our Bluetooth receiver, which is the HC05 Bluetooth receiver that can only transmit at a 10-meter range. So to increase the range, we suggest to use a process called Bluetooth telemetry bridging, which increases the range but also can come at a low cost. In summary, the aim of FlyFM project, which is to produce a mock-up of aircraft instrument system that can show the temperature, humidity, the altitude, and also the altitude of an aircraft has been achieved. But with further improvements and suggestion, it is hoped that the project can be more portable so that it would further expose more people to the idea on how this system can seem complex at first but can be simplified and made portable.